Hey everyone, Kevin here. Basically just going to go through my project number 4 walkthrough for this project. We were basically working with Keytimes. The idea behind Keytimes is they generate interpolated values for you for various keytime parameters of your choosing. The idea is that you could basically construct a scene pretty quickly without needing to resort to, fancy calculations or physics. In the demonstration that I'm going to show, I kind of use a blend of both to achieve the effects that you're going to see. For this project, we basically had to pick 8 various quantities. Some of the required ones are basically listed here, such as light source, viewing position, orientation or scaling of objects, and then RGB is various, as well as 4 additional quantities of our choosing. And so for my project, what I decided to do was basically animate a more science fiction or space opera themed scene. And so I'll basically walk through that next with you. So I'll basically go through the scene and then go through the code at the very end. Just as sort of a brief preview, these are basically just a summary of some of the main key time parameters that I'm using. I am simulating sort of the effect of the camera. I've included some hyperspace effects, ships jumping to hyperspace, or attempted to try to simulate swarms of objects, as well as some object exchanges, like this could be armament exchanges or shuttles ferrying between ships, some fade out effects, some planetary effects, and then some cool stealth effects. So just transparency, or not really transparency, but blending in OpenGL. So without further ado, let's go ahead and get started. Just do that here. Okay, so here's the scene. And right now, it's basically in auto camera mode. So this is using a keytime frame to adjust the camera's X, Y, Z position, as well as its looking point. I'll just let it run through once. I'm basically animating a 20-second animation here. And then once it runs through, basically I can go to a manual mode and just kind of focus on individual things. I did think about adding some hotkeys to kind of focus on various things, but I didn't really quite have time to get to that. Okay, so I think that's enough of the camera view. That's one key time parameter. I'm gonna turn off the axis too. All right, so now we are in manual mode, and so we can just kind of observe statically, but I guess just to start with the planets, each of these planets have their own lighting. I'm using basically the OSU set material function for that. The RGB values as well as the shininess also have their own key time values. So you can see the colors are changing as well as sort of their shininess. In addition, you can kind of also see their kind of breathing. I'm just kind of scaling their radiuses also with time, just to give them that sort of breathing effect. Now sort of focusing on the various ships. We got all sorts of Star Destroyers and ships flying around, but I think maybe just focusing on some of these inner ones, such as these 2 guys. I actually started originally with just one group, one jet. That turned into a group of jets, and then that turned into a bunch of Star Destroyers with groups of jets. So I guess just to walk through how I'm using key times in some of these situations. For the Star Destroyers, that's pretty straightforward. I'm just randomizing points each time you launch this. It basically picks several points to basically create a key time table. Based on those points, it creates the trajectory, and so they're just kind of randomly walking around. And then you also have basically for these clumps of fighters, I've used different ways to try to make them follow their trajectories. So for example, for this cyan group that I have my mouse or cursor on, they actually are using key time noise kind of simulated on an orbital path. So that's sort of combining some equations to generate the circle, which is kind of the underlying trajectory, but to kind of have them cluster around here on that path. I basically have given them XYZ noise, and so they're basically moving between XYZ noise overlaid on that path. And similarly, I kind of done something kind of like that for basically this other group of fighters that's circling around this yellow line. they're basically following around this Star Destroyer. So these fighters launch from that Star Destroyer and then kind of go on their own system orbital path. Oh, which is also using a key time frame of its own that's changing with time. And then this other group of fighters is basically following this Star Destroyer, but the noise is kind of induced in a different way. I'm using basically like a different kind of like delta, theta offset, as well as like a lift, and what was it? It was delta, theta, lift. I think it was 4 parameters, but anyways, they're basically getting shifted on different arcs of a circle. So it's like just a different way of making them follow along. And I did forget to mention this, but actually these fighters over here and a lot of the objects you see flying around, I also added like additional rotations based on like sort of the pitch and yaw. So it's basically saying what was my last point and where am I flying to next, and then it's basically, you know, applying some rotations to sort of keep their front end angled in the direction that they're going in. I just found that that gives it a slightly more realistic look. And so those are two types of sort of uses of key times for these groups of fighters. This bottom one is also another sort of example. I'm just using the same technique, kind of like using a bunch of noise on these. So if you just kind of watch these guys in the purple box kind of fly around, that's kind of like the key time noise that I was talking about. And then for time, they basically are using kind of the same trajectory as the Star Destroyer, and then they follow it around. So again, just kind of focusing on that, flying around with the Star Destroyer in the box. That sort of denotes the key time noise box. And then they shift around and then they continue moving around. Okay, enough of that. Looking at a few other parts of the scene, you have this group of fighters kind of like arcing around. That path is also controlled by key time. If you watch it long enough too, you know, they also kind of like scale out of existence and also fly closer to the planet. I think on this current arc here, you'll see they'll get sort of small and fade out. That's using key time effects. If we watch this Star Destroyer, he's going to launch a volley into the planet. That's basically simulating exchange of key time effects. I'm basically using the key time of this Star Destroyer. At a certain time, I'm saying use that key time value to basically construct another key time for the missiles and, you know, lead that basically to this planet. So that's kind of an example of armament exchange. And then similarly, these fighters you see that are more golden colored flying around. If you kind of watch them, they're sort of following and moving to the starship. So we could watch that again from the start. You know, if you could see a few that are basically launching around, and you could see that they're basically heading towards different Star Destroyers. And so the idea that I'm using there, I'm basically, I have a sketch of it. But basically, each of these objects have their own key times, and so basically, you could use that function, like, you know, get value at time or whatever, to basically interpolate, you know, like set the ending points of the new key time, and then you could set additional key points in between. But it kind of like gives you that illusion of, you know, shuttles faring in between objects and so forth. Another use of key times, they basically have this disco transparent ship just kind of floating around here. He basically has some transparency effects using key time parameters. So let's kind of appreciate that for a second. And then I think the last thing I just want to point out, I also have sort of some Star Destroyers that sort of fly in, kind of waiting around for a little bit, and then they're going to jump into hyperspace shortly. So now they're speeding up, and then zoom. I don't know if you saw that, but they basically like stretched a little bit before continuing on their way. So basically I'm using a scaling key time for that, as well as just a positional key time to sort of generate that illusion. So we can watch that one more time, and then I think that should basically conclude this. So, yep. So that's basically this scene. Let's see, how long is this video? I could maybe walk through the code if it's not too long. So we're at about 10 minutes. I'll try to go through the code real quickly, I guess. I don't want to keep this too long, but let's see. Alrighty. So keep the scene on the side. Oops, sorry. There we go. And then I guess first thing I can go with the init. Let's go to 29. So starting with the init list, this basically just shows the various display lists that I'm creating and invoking and the display function. So basically I have a wall. Oh yeah, I have a wall in here that I initially had added to basically like provide a little bit more contrast before I had set up the lighting. But I basically just toggle that on and off. I'm using a number of objects. I got these from free3d.com, and so here you can see I have the Star Destroyer, some missiles, some jets. I'm applying some initial transformations to them and some scaling effects since they weren't all the same size. They weren't all centered on 0, so just to make things sort of consistent, made sure they're all facing in the same direction, scaled appropriately, and located at the origin essentially. Some for basically generating the orbital paths and shapes, and then basically for the orbital box that you see here, and then basically I'm using OSU sphere for these planets. And so that basically covers init lists. We can walk through init graphics next. That basically has more of the keytimes. And so here you can see we have a plethora of keytimes. Some are a little bit more straightforward. As I mentioned, some of the Star Destroyers, they're basically using random points to sort of construct their keytime tables. They have sort of random trajectories. So you can see that's what I'm using here. Using a random sign and then sort of a random uniform distribution between 0 and 1, for example, and then some sort of constraint, sort of radius or box size. Similar for Destroyer 3, I have keytimes for the positions of the transports, and you could see for these guys, these keytimes or the transports are actually functions of the destroyers in this case, or the planet positions for this case, and so that's simulating the interaction between those objects. I have keytimes for the orbital paths, system orbitals. This is basically for the jets. Yeah, and various other keytimes. So lots of keytime values, some for the RGBs, as you can see here, or the camera position. So not going to walk through all those, but maybe we can go look at the display function next. Okay, so for the display function, it's pretty much the boilerplate code. I basically came in here and made some edits. So you can see here, basically have the now time msec definition that the key time values are going to be calling. Here, basically, I'm using a key time basically for the camera auto view. So if it's in camera auto view mode, it's going to basically use those key time values to jump back and forth, as you see on the right-hand side. A little bit further down, I started basically adding some of those features. So drawing the walls, if I basically have that set on to true. I had an option for playing around with basically planetary or basic lighting, but this is basically just setting the lighting for the planets. This next scene here is basically doing the patrols for the squadrons of fighters. So you can see here there's some calculations for trying to get that more realistic roll for the pitch, roll, and yaw. Overall, I'm using mainly just the pitch and yaw, and that gives me a realistic enough look. If you use both pitch, roll, and yaw, it still doesn't always look quite right with objects that aren't completely like axisymmetric. Like usually for something that has like an upside and a downside, I still think that it's missing like some mechanism of self-rightening overall. But yeah, this is kind of an example of what I'm doing for the fighters, for example. And so it's a lot of copy and paste. This could have been modularized a little bit more, but overall this is kind of the idea. I'm using arrays of keytimes actually, and so by using arrays of keytimes, it's very easy to loop over them in this case and generate these swarms of fighters. So I don't know if I want to call it anything else. I think that's basically the main idea. So I hope you enjoyed. This was kind of interesting, kind of fun. I kind of got into the weeds, I feel like, with playing with all the little fighters. Sort of awakened something in me that, I really liked Star Wars when I was younger. So it's like being able to create your own little ships and have them fly around. That was kind of cool. Okay, yeah, hope you enjoyed. Sorry the video's a little bit long.